Welcome back to Basic Mathematics. In this video, we're going to be looking at solving proportions. Last time we were talking about ratios and rates, and I explained that proportions were going to extend the idea of ratios and give us some powerful tools for problem solving. Before we can get to problem solving, let's spend some time exploring exactly what we mean by proportions. So let me get my head out of the way and let's dive right in. A proportion is a claim that two ratios are equivalent. Symbolically, we can write that as a fraction a over b equals another fraction c over d. When we have a proportion to work with, we can determine if that proportion is true using a tool called the cross product test. All right, so just getting back the same proportion we have before. The cross product test asks us to look at the terms that are diagonally across from each other, and product is the result of multiplying. So we take these terms that are diagonally across from each other and we multiply. A times D B times C. If these terms are equal to each other, then the proportion is true. If these terms are not equal to each other, then the proportion is false. For example, I might look at a proportion. I claim that 2 and 5/8 over 2 and 4/5 is equal to 3 over 2. I can test if this proportion is true by simply multiplying the cross terms. So 2 and 5/8 times 2 and 2 and 4/5 times 3. Right? The terms across this way, the terms across that way. I want to know if this is true, so I put a question mark above the equal sign to say I'm trying to figure that out. We know that trying to work with, we know that trying to work with fractions, the best course of action is to rewrite them as improper fractions instead of mixed numbers. 8 times 2 is 16. 16 plus 5 is 21. Uh, 5 times 2 is 10. 10 plus 4 is 14. And if I multiply here, 21 times 2 is 42. 14 times 3 is also 42. And I get the claim that 42 over 8 is equal to 42 over 5. We once again have a situation of one fraction equals another fraction. So I could use the cross product test again. But in this case, I notice the first fraction has a denominator of 8. The second fraction has a denominator of 5. Those are definitely not the same denominator, even though the numerator is in fact exactly the same. Same numerator, different denominators is always going to give me a false result. Compare that to a different set of fractions. One and a third over 1.5 equals 2 2/3 over 3. Once again, I can look at the cross products. 1 1/3 times 3. 1 1/2 times 2 2/3. And if these two things are equal to each other, then the proportion that we started with is going to be true. Once again, in order to do arithmetic on fractions, it's better to have them as improper fractions instead of mixed numbers. 3 times 1 is 3, plus 1 is 4. So I've got 4/3 times 3. I've got 3/2 times 8/3. Twelve divided by 3 is 4. 24 divided by 6 is also 4. It is definitely true that 4 is equal to 4. So these two fractions, the ugly fractions with mixed numbers all through them, were in fact equal in the first place. Find the value of x such that x over 7 is equal to 12 over 19. Here we start getting into one of the most powerful tools that we have in mathematics, and that is the variable, the unknown. I do not know what x is. I don't know what number goes there. But by putting a placeholder, such as x, in that spot, I can write out the kinds of arithmetic that I want to do to that thing and start working through until I can find a way to conclude what value that number must hold. In this particular case, x is in a proportion, so I can start off by using the cross product test to conclude that 19 times x is equal to 7 times 12. And 7 times 12 I can calculate is 84. Right. Now from here, if 19 times x is 84, I can take advantage of the definition of division as the inverse of multiplication and conclude that it must also be true that x is 84 divided by 19. 84 divided by 19 does not work out evenly. In fact, it's a fraction that you can't really do anything with because 19 is a prime number. So I'm just going to leave that as x equals 84 over 19. If you really wanted to, you could write that as a mixed number instead. 19 fits into 84. It looks like it'll work 4 times. 19 is close to 20, 84 is close to 80. 4 times 19 is 76. Subtract that off, you get 8. So if we wanted this as a mixed number, we would give the answer as 4 and 8/19. Depending on context, improper fraction might be fine, mixed number might be the better choice. Solving a proportion like this, possibly the most important skill in mathematics that any student can pick up. Proportions are incredibly powerful as a tool for modeling situations in the world. In the next video, we're going to look specifically at that, start learning ways that we can model situations using proportions. For right now, I'd like you to take a look at the assignment, practice solving proportions like this, and I'll see you in the next video.